Welcome back to part two of lecture 18. You can tell there's a little bit of time has elapsed because the hair meter is telling you that. Okay, so I'm going to share my screen again. And I hope you guys had a good break. And hold on, that's not what you want to see. Let's stop it again. Okay, there we go. All right, so again, we are in the middle of lecture 18. And as you can see, we were talking about how important it is to be part of a team. Packaging is integral to the entire process for automotive. Packaging ties into every aspect pretty much along the way. And being part of the team it makes you a great asset. You can be a liaison as far as information sharing, and it makes it easier when you're trying to implement packaging. If there's a challenge and you've developed a really good relationship with other areas, they will go above and beyond to help you and make sure that things work. So just keep those things in mind. All right. Next slide. This is, which I wanted to talk about some of the information that is important when you are working in automotive packaging. So these are some things that are important, say, for the purchasing team. So when I talk about key members, purchasing is important because they're signing the contracts. They are one of the first groups that you'll be working with besides the program manager. When you start, and like the program manager and finance to start with, but purchasing would be one of the teams you start to work with when you start to look at developing the packaging, because they're going to supply the information to you on who the suppliers are. When the suppliers are awarded the bids, or when they know they're going to award the bids, you might even start working with the supplier early to understand what parts are you shipping, what packaging are you proposing to ship to us so that I can approve it. So some of the information that is relevant to packaging when you're working with purchasing would be, understanding the supplier location. Okay. If you can get information from the supply chain team or logistics team to have freight studies done, that will help you understand what the system days are, especially as you start looking at expendable versus returnable. The volume that is being planned. The program team may come up with a volume that they've estimated, that they forecasted. As they go to justify the business, sometimes they are going to say, we're going to ship 500,000 parts. But when you talk to purchasing and you understand the volume, what they're bidding against may be actually something like 250,000 or 300,000 parts a year, or 400,000 parts a year versus that 500,000 parts. The reason why you might see that is when the program team starts to initiate a project, they have to do a justification to show that, making this new part or this new vehicle for a particular customer or whoever they're supplying it to, that it is going to be profitable and have a certain profit. And many times they will be conservative on that. And when they're conservative to estimate a new program, they will usually go high on the volume. So that's what you'll see. Other things that are important would be the size and the weight of the part. I cannot tell you, if I had a dollar for every time I ask a product engineer what the size of the part was, and they said something to the effect of, why do you need to know that? Then, there's some education that has to go forth, because they just literally think you're just going to pick a box out of, I call it the magical levitating warehouse. And this package is just going to arrive and do everything it needs to do. And there's no thought put into it. It's just a box and boom, it just shows up. So sometimes you have to educate them on why it's important for the packaging engineer to know the part size and the weight of the part so that they can package it, which leads to the next piece of information that's relevant to you and to purchasing would be the pack size and weight. Some companies, try to estimate what the cost of corrugated is going to be based on the weight of the material, size of the material, those sorts of things. The pack density is important to know how many parts are going to fit in the pack. Sometimes there's a goal. Sometimes your goal is going to be based off that tack time. Sometimes they are limited to space, and you're trying to get as many parts in the pack as possible, because for each part extra that you can get into a pack, that is actually could lead to fewer trucks over time. We went through those calculations in the prior weeks about the difference between 1,000 trucks versus 2,000 trucks over a 5-year period, what that looks like and the impact it can have, and making things that seem like changes that seem like very small incremental changes can really impact your number of trucks and your overall freight cost over the lifetime of a project. Next, we talk about those packaging costs. So the packaging costs would be part of the request for quote. So when a supplier has a part that they're proposing that's going either to their customer or, if it's going to an OEM, they will say, this is how much this part is going to cost. And they will include the packaging cost for that. So again, if you have 100 parts in a pack, you would split up, let's say that box is $1 and you have 100 parts in that box, you're going to spread out the cost of that box over all the parts. So if you've got 100 parts in a box that costs $1, that tells you that they're going to save for a penny for each part is going to be spread out amongst those parts. So if you've got one part that's equal to a penny, you put 100 of those in the box, now you're at $1 for your part cost. So that's how they do it. It is, again, most of the time listed in the request for quote if you're doing expendable. And it's important to know, because if you're end up doing a expendable versus returnable cost, then you can say, we know it's going to cost a penny per part for an expendable. We know that over time it's going to add up to $5 million, but how much would it cost for the returnable for that same volume, for that same period of time, with the calculated system days and the calculated fleet size that we'll need? Next, another thing that's important is to understand, like, getting, when you can get production intent samples. Now, the production intent packaging and trial packaging, depending on where they are in the program and how difficult it is to build the parts, you want to, like I said, early on, as early as possible, do a fit check so that you can start really working on the packaging. When you're ready to do transit testing, now you're looking at production intent packaging. You want something that's functional. You don't want something that's damaged already to do a transit test to look for damage, because now you've got a damaged part. You transit test it, you open up the box and you see damage. You don't know if that damage came from before or if that damage was exacerbated during shipment. If the unit was functional, but maybe because the part was compromised, now is it not functional because of that hit and it was already weakened? It's really hard to say. So you really need functional parts that work going into any transit testing. And one of the concerns for many of the team members might be, well, we don't want to give you good parts because we don't want you to break them. It's very important to really let people know that, emphasize that, yes, I'm getting this packaging, I'm getting this functional part or these functional parts enough to fill up the pack to run a transit test, but we design the pack confident that the packaging will pass and the part will still be functional and will not be damaged. So the packaging tests whether it's a lab test or a road confirmation test, the goal is to confirm that everything's fine. So the vast majority of the time, virtually all of the time, the packaging will pass the test. So, you can let people know that the goal is to confirm. The goal is not to break the part. It's not a test to cause damage, to see where the damage levels are. The goal is to confirm that the design that you have is, does meet the requirements and will protect the pack. So most of the time you'll be able to use the part. I literally can't really think of any time in over 30 years of experience that I've seen packaging that fails to such a level that the parts are unusable. So it's more of a confirmation test. So again, let your team know that they will be more apt to give you parts to use if you say, this is just to confirm what I'm doing. This is just to confirm the packaging works. Everything we know says that it will work, and this is a formality to confirm it. Very rarely do we see failures where the part is not functional, but the goal is to confirm and give you back a part that is functional that you can use for something else. So just, to allay their concerns and fears, let them know that. Another thing that's important is to understand what your fleet size is. And again, we talked about that. We'll go through that later. You're basing that on your volume of production, how many parts are going in the pack, and those system days. And then also it's important to know the freight impact. So when I did the fleet calculations, I did not calculate the freight because we went through it so you understand how that works, but you are going to have to be able to confirm the freight rates with your transportation or logistics team. And then you can add those costs in there. So if you give them information on like what the pack is, how many you're going to fit on a truck, and how many trucks they plan to have, they can help you with the cost per truck and calculate that to come up with a pretty good estimate. And also, things like the pallet size, having standardized pallets, and making sure that your unit load height is at such a height that you can double stack or triple stack to get the full height usage in that trailer, because you always want to get as much into the trailer as you can. And even if you're shipping, say, multiple parts from a supplier to you, or you're shipping from your location to your customer, and you're shipping mixed loads, or maybe it's coming from a cross-dock facility and they're putting mixed loads in, if you have these modular units, then you know that any of these pallets that are 48, 45, or any of these bulk bins that are 48 and 45, you're just pulling, to add 52 to get on a trailer if, you're too high or whatever that is. You just modular, so you can count pretty easily how many are going to fit. And then, you also want to look at, with your purchasing team, any additional consideration. So I think an example of that would be, for one, contracts for things like leasing. If you're looking at leasing versus buying returnable versus using expendables, those are all sort of things that you want to look at that would be additional considerations. Another thing would be if the RFQ that's sent in, the request for quote that's sent in from the supplier early on, they're suggesting a corrugated box, but that for whatever reason, this corrugated box is not going to work either line side, or maybe some ergonomic reason, or maybe it's a clean room. There may be dust or something, there might be, whatever it is, there may be some other things that will cause exceptions to the original request for quote. That request for quote is your opportunity to review and approve or disapprove the packaging. early on and put in your input about what your expectations are, where that packaging proposal is not meeting your set standards, and move from there. You also want to make sure that if there are any agreements with purchasing prior to what you're looking at, that you understand what those are, because there's nothing more fun than working on a design and then finding out that the contract states it's going to be a certain price, and it blows out anything that you'd be looking at for packaging. It can really narrow down what options you have. So you might be working in a pretty constrained framework of what packaging you can use. So those are just things you need to understand as you go through deciding like what type of packaging, what standards you have, and those sorts of things. This is talking a little bit about when you're evaluating the packaging. So I talked about inputs that go into the teams you're working with, and then they're submitting packaging proposals, and then some of the data that is relevant between you and the purchasing team. Now you're starting to dig in and you're working with those suppliers that have been sourced that purchasing has told you about. You're looking at their packaging, you're understanding the parts. Now you're starting to work more with the manufacturing team as well as the product engineering team, because you want to make sure you have a really good understanding of the parts. So when you start evaluating the proposals from your suppliers that they've sent on whatever standard packaging information or data or request or proposal form that they give you, and if your company doesn't have one, I would recommend that you do that. Excuse me, that you actually do that. Come up with forms and give them the forms that would be useful for you to evaluate the packaging. So some of the things you want to see in that form would be the details that would include photographs. So you always want to have photographs of the part so you can reference part. One of the things I've noticed is that you will have companies that they will have I think I mentioned before, they'll have like the code name, they'll have the actual vehicle name, then they might have another code name that they give to their suppliers because they have all these high-tech private, secretive new vehicles or products that are coming out. They don't want people to know. So by using code names, no one's supposed to know. But generally what I find is people may use the code name interchangeably with the part name or the vehicle name. Another thing that I'll see is that, again, different teams will use different code names that are working on the same product, but also even from department to department. So maybe you're talking to purchasing and they're calling it like the big body part, right? And then that's what purchasing is calling it. You go to the product engineering team and they're calling it like a soup bowl. They might have some weird name for it. And then you talk to the manufacturing engineering team and they're calling it the slip and slide, just making up completely outrageous names. But I've seen things like that where they call something the same part 3 different names, and then you go to you talk to the supplier, and the supplier is calling it the bow and arrow. So you have to understand what those parts are. So you want to have part number, you want to have photographs, you want to have a description, and then as you evaluate the packaging, the information that you should receive on those proposals would have information like the location of the supplier. And I talk about that, understanding the freight, having a freight study, because if you don't know where these parts are coming from and where they're going to, it's really hard to package the product sometimes. And I've talked about this before, what it looks like when we talked about during the part of this course on testing. If you're taking something, shipping it by ocean on a boat is totally different than if you're shipping it by air, which is a completely different scenario in either case to running on a rail car. And then on a box truck, a small truck that's running in a short distance versus an 18-wheeler that's running up and down the mountains or a bumpy road or potholes or, in some place that's not paved. So all those different scenarios can have a totally different effect to the packaging. So you need to understand what that is. Again, the volume, you see that part, that information for the volume that kind of goes across multiple teams. That volume is important for you because you're trying to calculate things like system days for returnables and costs, but it's also important to understand from a standpoint of line side, how many of these parts are they going to be handling at any given time. Again, you see the part size and weight, pack size and weight. You see there's, some redundancy that helps you calculate the fleet size, understanding the pack density, and any additional considerations. So you can see very similar to things for purchasing. And again, this is what you're evaluating. So notice a lot of information that we talked about that's relevant to purchasing. You are evaluating those things, confirming those things to make sure that what purchasing told you is what they're giving you. So if purchasing told you that you plan to use a returnable tote, but they're showing you a corrugated box, that's something that you want to make sure that you understand, because if they're looking at purchasing things as a returnable tote, the way that they pay the supplier is totally different than how the supplier is charging for an expendable pack. If you will remember, we talked about how the supplier might purchase, they will physically use the cash to purchase the packaging, but the ownership is transferred over to the OEM at that time, and then they pay back the supplier part by part over the life of the program. So, those are just things to understand that can have a huge impact. You saw the cost of expendable packaging versus the cost of returnable packaging. So that can have a huge impact on the contract. Okay, next, these are some considerations that you need to look at for design. You want to understand who owns the packaging. Is the supplier owned, or is it, that you own it? Or if you're the supplier, is it owned by the OEM? This also kind of gives you guidelines where, if the supplier owns packaging and the supplier is external or outside of the company, then the supplier designs the pack. You also have, and then you have it where the OEM would approve the packaging. However, an example, you're like, what would be an example of when it's not an external supplier? For example, I worked for an engine plant. The engine plant was owned by the car company. We were making engines and sending them directly to the OEM plant where the vehicles were built. Well, we were the supplier, but we were also the OEM. So we owned the packaging at our plant, but also was owned by the car company. So that would be an example of where it was handled a little bit differently. We considered our packaging because on the books across the board, from a corporate standpoint, it was all owned by us, no matter what division we were, no matter which side of the table we sat on. I mentioned again the contract verbiage, when you're looking at not just leasing, but you want to look at the purchase order. You want to at least understand and make sure that from the purchase people, what is on that purchase order. If you don't actually have direct line of sight to it, because that will determine again whether they are adding the cost of the packaging per as a piece price, which, like I give the example of the corrugated box, that's $1, you have 100 parts in there. So they're putting $1 per part on, a penny per part, I'm sorry, I should say, a penny per part to get to that dollar per box. Or are you looking at amortizing over the life of the product, the vehicle? So that would be an example of, you have the returnable bin, the supplier is using their cash to pay for it, but the OEM, the customer, is paying back that every single time a part is shipped, every single time a part is made. They're slowly over time paying back that money, and they've already taken ownership of the containers. Other things to look at would be like, who's managing the containers. So in the case of a lease program, who's managing those containers? So the lease programs say they manage the containers, but if internally you're not managing containers well, they can say anything, and you could incur a lot of extra charges because of your level of disorganization. So those are things to keep in mind. What are all those fees? And things like maintenance, who is going to clean the containers? If these are containers that are holding greasy parts or oily parts, or there's just a lot of dirt, or maybe, at some point these packs can get stored outside and they need to be, they get disrepair more quickly, or they break down more quickly. Who's responsible for maintaining and repairing that packaging? Another thing is, who's responsible for the packaging? I mentioned this, kind of touched on this in the last slide. Is it the OEM or the supplier, right? So many times the OEM, the packaging engineer, they may actually work on the design with suppliers. And then they also will look at things like, how is this packaging handled? Is it cross-docked? Is it coming in JIT to the plant? Are they doing, purchases as they need it on spot buys? For example, it'd be the terminology where they're just buying as needed. And when that happens, you also want to make sure, who's responsible, but then also all those different factors on how the product can come in, how long it's going to be stored, the quantity that's coming in based on how it's brought in, what does the contract look like for that? Who's paying for that? What are the exceptions? When would there be, something that would cause a change for the packaging? And, what triggers those things? It's a price change, or maybe there's a design change. Those things need to be thought out. I can think of a part right now, one of my clients, where they made a part, they added an extra piece to it. Now this part is about an inch or two bigger than it was before, but it does not fit in the packaging now. So, what do you do in that case? Have they committed to packaging, and have they started kicking off any tooling for it? Can they stop that if it's been if they've already started to pay for or they put in a PO for the tooling? What kind of things can they do? So these are all things that you want to understand before the packaging is finalized. Okay. This beautiful eye chart is basically a flow chart for launch processes. So this is very generic, and I've shown some of this before, but as you will see, you've got, I'm going to try to annotate here a little bit. Okay, so here, this is the beginning of the ideation of the program, where they're like, I have an idea. We have this new vehicle. It's gonna, go 120 miles per hour on the freeway, self-driving, and you'll be able to drive it underwater. and it'll be able to fly. This is a concept. So that's where you are right here, right? You're just coming with the concept, and then from there, from a packaging standpoint, they will give what's called baseline considerations, where they're saying, okay, this is what the vehicle is going to do. We're going to sell 20 million of these in the first year. And second year, we're going to sell 50 million. Whatever it is that they come up with, they will have all that information here. This will be made in such and such plant, you know, or maybe it's going to be made in 2 plants. So that's just where they kind of give a very broad overview of what they think the vehicle is going to be. From here, you know, some of the inputs that would be important for the packaging engineer would be, you know, are there any part drawings? Are you taking parts that are currently being made and you're reusing them, or maybe you're updating them? I think an example that I think about would be like headlights. Headlights change for new vehicles. So how much of the headlight is similar? It's going to be the same length, but maybe the shape is going to change. Well, you know that it's the same length, so it's probably going to fit in the same pack. You know, those are some of the things that you're going to look at. So you may have some concept drawings of the new part, but you also may be able to take old parts and leverage those. Also knowing what the volumes are, you know, like I said, they said maybe we're going to do 5 or 10 million. You know, those are sort of things, those are the kind of things that will help you decide, are we going to have a lot of returnables for this product, or are we going to use more expendables? Those are some of the inputs. From a standpoint of outputs, these are some of the things that at this early part of concept development, from a packaging standpoint, what I would say you want to strive to do. So you want to look at, you know, what are your packaging concepts? And then you want to kind of get an idea of, you know, line side, what are they doing? You know, if it's a large volume product, many of the parts may be going into bulk bins. Or if this is more of a custom item and you're going to, you know, have more things that are JIT or made to order, then you might have more kitting. So, you know, those are things that you might start thinking about, and how those different scenarios could greatly impact the type of packaging that you have. Okay, here you've got the first gate where they've said, okay, we come up with a concept. We think it could work. We're going to start moving forward with development of this. So these gates are decision points. The first one is, do you want a concept for a new vehicle? Yes. Okay, well, what does that concept look like? The next one is, yep, we've got information we think is viable. Are we going to go forward? Yes. Okay, so now we're going forward. Now we're at the validation of the concept. So this is where business cases might start getting made by the program team. Things like the volume, the inputs would be things like volume, if they have multiple colors, or if they have right hand, left hand, you know, if they're going to be making, let's say they're making things for the US and for overseas. So in the US, you know, your driver's side is on the left of the vehicle, but in other countries, the driver's side may be on the right side of the vehicle. So, you know, those are some of the things you're looking at. How complex is this getting? Are you going to have different colors? So let's say like colors of your seat, your interior. Are you going to have it where it's all just like gray cloth? Or are you going to have like 2-tone suede versus, you know, a 3-tone leather? You're going to have like monograms, that kind of thing, you know, or what are all the iterations you could have? You can have cup holders that light up versus regular cup holders, a lot of different radios. You know, this tells you what the complexity is. And the more options you have, the more things you have to think about for packaging, basically. You know, what about aftermarket? What are you gonna do for aftermarket or service? And that would be, the aftermarket would be, let's say you have your car, it's being made, and you decide to do your own oil changes. You would go to the dealer and you would buy an oil filter in the aftermarket pack, or brakes or whatever. You're going to do that work yourself, or you have your mechanic that would do it. So there, you know, you could actually go to a dealership or a some distributor and you could buy that part in an individual pack. And it would probably have the logo on it, the company branding, that sort of thing. The other option would be like service parts. So service parts are parts that, let's say now you take your car to the dealership to get an oil change. At the dealership, their service parts would be maybe a corrugated box with, 20 filters in it, the same filter, but they don't need to have fancy branding. They just need to know like which filter this is, what vehicles would this be used on, that sort of thing. Then you have like versus the production packaging, which is going to be, is it going to be the line side returnable or is it going to be expendable? All those sorts of things you're looking at. To determine, because you need to understand, like from a production standpoint, what sort of parts you have and how many different iterations, again, that you're going to have based on whether it's an aftermarket part, service part, or going straight into the vehicle. And then things like the math data. The math data is going to be information is coming from the product engineers about the part. So you might have a 3D drawing, or maybe they will give you a 3D printed part, and you can start asking for that, telling them that you need a 3D printed part to understand how big the product is and what some of the main characteristics of it are. You're not looking at this point of whether or not the part is going to work. You're looking at how many parts can you fit in a pack? What packs could you use and how many parts will fit with these different types of packaging? And then you have, understanding those part characteristics. Those are inputs that are really important to understand. Is it something that's sensitive to electrostatic discharge? Is it sensitive to moisture? Do these parts need to stay oily? Is it a Class A surface? Are the parts machined? All these different things that can affect the type of packaging that you use. Then your outputs are going to be information on estimating a cost of whether or not you're paying a piece price over time for expendable packaging, or are you going to have a fixed number for fleet, and how much will that investment be? Because these are, again, a capital expenditure. So it's considered an investment versus an expense, where the cost that I mentioned would be an expense of like the expendable corrugated box that you use once, throw it away. That's an expense. That's something that we spent the money and we're going to spend it. It's a part of doing business. But if we invest and buy these returnable containers, now we own it and it's treated a different way on the books. And then the estimate for packaging, you want to understand what you think the packaging cost will be and compare it to what your supplier is giving to you, because you want to make sure that your supplier, if they're giving you a pack proposal with the cost, that they're not using packaging as an area for profit. And also, if you are the supplier and you're sending to your customer, you want to make sure that your estimate is fairly accurate, because you don't want to say that this box that might cost $1, you don't want to say it's going to cost $20 or $5, because that's going to throw off the profitability of the program, and it may make you less competitive than you would have been if you just gave them the real packaging price and didn't add a large margin to it. So you got to be realistic on what those margins would be. Next, from here, we go back up, decision point. Okay, did we validate the concept? Yes, we did. And we really want to keep moving forward with it. Now you're in that phase where you're like finishing up designs, working with suppliers of the parts and suppliers of the packaging, and you're starting to, set up testing. So you've done a fit check, you're getting prototypes at this point. You're doing what's called an FAI, which is a first article inspection. So there are going to be multiple areas where there are going to be opportunities for manufacturing to test the product to see, how does it run? Is it functional? All those sorts of things. So they will bring in parts and do very small trial runs, which we talked about earlier. So this is where you start having packaging for those trial runs. Many times people are tempted to just throw them in whatever box they have available and ship it. But from a packaging engineering standpoint, this is one of your early chances to start driving the suppliers towards finalizing a pack for production that works, that meets your requirements. Because sometimes they're just like, I have this going on right now. We're just going to put it in this pack that we have right now, and then we'll worry about it later for production. But sometimes they're like, this is the pack we plan to use. We'll give it to them. They'll like it and they'll get used to it, and we'll just stick with that. Even if it doesn't meet their requirements, that's okay. We'll just, whatever. So you just want to make sure this is your chance to test, and test again. Review, lab test, trial test, check it out. Have parts that work, have the ability to understand what the distribution routes are, and run you've got the confirmation in the lab that should match the transportation profile. And then you also would use this as your chance to do transit testing. Let's see. Next, your output is going to be test results. So these test results are important because this tells you, is the packaging okay? Yeah, maybe the product passed, or maybe there's something you don't like. Maybe you need to tweak it. So this is where, you still have your chance to kind of tweak things a little bit before they move to the next gate, which would be, okay, we got our phases done. We've got our design pretty close and locked in. Now we're ready to start getting ready for launch. So here, the function is, you start having things like production intent parts, production intent packaging, you're validating your packaging, the production team, the quality team, the program team, the engineering team, they're all looking at validating the part. So you want this to coincide because they've already started running, production runs, testing. When I say production runs, they're test production runs. They are small runs to start seeing, how does this work? How do we work out the kinks? Are we okay from an operator standpoint, or do we need to tweak it? And this is the chance for packaging engineering to be there. Put it in packaging that looks a lot like what's going to happen in production. Even though it hasn't been approved, you want to get as close as possible as you can when you're testing, so that all you have to do is, review the proposal forms from your supplier, if that's your function, and you can start approving the packaging. Sorry, it's late. Okay, getting old. All right, so then next you have, once you do approval, you're looking at deploying the packaging out. So you've kind of gone through this whole process. It looks pretty straightforward, but there are a lot of moving parts at this point. You've got purchase orders, you've got proof of shipment, proof of delivery. You've got review to make sure the right amount showed up. You've got, information on your packaging and testing to make sure that everything is working according to plan. And then here, once you've done all this, now you've moved up to launch. So they've made this at this decision point, this gate. Okay, so are we been prepping for launch? Are we ready to launch? And they say, yes, we're ready to launch. So you're at this phase of launching. And this is where you start seeing the purchase of packaging, purchase of parts, things start getting delivered. If you have determined returnables for any of your products, you want to make sure you have implemented the process for returnables. What does that look like? How are they returned? How do you recognize when you have shortages? all the things that could be an issue, when you have constraints, when you start having shortages, all these things, you've already got this process laid out at this point, and maybe you're even training people. This is where you're going to see purchase recs and purchase orders come through, and the new packaging is your output. That new packaging arrives and starts getting used in production. So I want to run through this again. This is kind of what we've been talking about the whole time. This is like the project management form where you see the different phases. You've got phase 1, 2, 3, 4, 5, all the way from concept, all the way ending at launching and ongoing production. So and these are just some of the things that you would be looking at as you go through this process. Okay, so I mentioned that packaging standards are important because it gives you, it can reduce complexity. It makes things easier. You see how when we were calculating how many parts are on a truck, how much easier it was when you knew you had a certain number of parts in a bin, and then you know exactly how many bins fit on a truck. So now instead of literally counting one by one, now you are I know what the quantity is in this pack. I know how many of these packs are on a pallet or unit load, and I know how many of these unit loads are in a truck. So you're just basically multiplying number of parts by number of primary packs by number of any secondary packs if you have it on a trailer or a rail car or sea container, whatever it might be. It's much easier to do that when you have standards. I mentioned having a pack proposal form, but first you have like an inspection form would be good to have. So the inspection form would be when you start looking at like first article inspections, or when you're doing fit checks, it's good to have some sort of form to say, okay, this is what I'm inspecting to, this is what I'm looking for. Does the part fit? Are there any parts sticking out? Is there anything that needs to be protected that's going to break? Is this oily? Is it packaging that is compatible with oily surfaces? Is this pack easy to clean? Whatever your standards are for a particular part or particular types of parts. So many times you'll see types of packaging grouped together, like you saw engines are on racks, powertrain parts are on racks, nuts and bolts or fasteners will be in corrugated boxes, trim or large body panels are going to be on racks as well. So you just kind of see you have groups and patterns. So when you do inspection of your packaging, you already have an idea of what it should be. So if you have these long trim parts and they show up instead of on a rack or a large bulk bin, if they show up in a crate or just on a pallet, stretch wrapped on a pallet, that's already a red flag that it's not meeting your packaging standards. Or maybe you have metal strapping, this stuff comes in, stretch wrapped on a pallet, and then it is banded with metal banding. Also the red flags go up that when I inspect this, that it does not meet the standards for automotive. Again, understanding if you're doing any rentals or leasing of containers, then what is the return process? How are you getting charged? How much money is this going to cost the company? Is it going to save money in the long run, or are you actually throwing away good money that you could be using for something else? Again, I can never stress the importance of pallet standards. You got pallet standards that are, really important all day long, that you have that you see there can be a lot of confusion. You see when you have proliferation of pallets, not only is it confusing because now you got to try to figure out what fits on a truck, but in addition to that, the more custom pallets you have, the more expensive they are. Versus if you buy standardized pallets, people that are experienced in building these standard pallets, they will, they can give you a better price because they're making multitudes of this 48 by 45 pallet. So I would say you probably don't want to buy an automotive pallet from a pallet supplier in, say, Minnesota that's supplying to General Mills or Target, right? Because they're going to be using a certain type of pallet. It's probably not going to be automotive. And for them to make an automotive pack, like a pallet, they're probably going to charge more than if you go to a pallet supplier that's in the Metro Detroit area, because all they're doing is making automotive pallets, because that's what they do. Vice versa, you wouldn't want to go, say, have Target buy or Walmart buy pallets from an automotive supplier, because now the way they fit on the truck is going to be different. All the boxes that were, pallet patterns are set for the 48 by 40 grocery pallet. Now you got to fit them on 48 by 45 pallets. It can just become very chaotic and disorganized. Make sure you have, and also they like the AIAG standards, following those things. Those are good guidelines for people that are experienced in what you'll see in the automotive world and driving towards those standards. Same thing with rack fabrications. Under rack fabrication, understanding what your standards are, what kind of things you're looking for, what type of parts go in racks, really in general, what type of parts go on different types of packaging. So many companies would kind of already lay that out, say, the racks are going to hold engines and trim parts and headliners and thin glass, things like that. But totes are going to hold, smaller items like the wire harnesses, those wires that are plugged in your dashboard, behind the dashboard, those sorts of things. They might come in totes. What needs to have dunnage or Class A parts, those are some things that you look at for standard. So, this goes with, like I said, racks, but anything else. You want to have a set format for your fleet calculator. So you don't want to, one time you calculate the fleet with one thing, with some factors, another time you do your fleet calculator and you add in a different factor. An example would be, let's say you normally add 10% for loss, right? But this time you're like, oh, we want to save some money. We're only going to get 5% extra for loss, but you know that you lose 10%. You're still going to end up buying those. Now, actually could be more of a pain because you've only been approved to buy 5% of the containers extra for a loss. And then when you run out, now you got to do a whole new justification and they may not approve it. And now you're stuck without enough returnables. And then you start shipping in more backup expendables. And now you're paying more for those backup expendable fees than you would have if you just put in the 10%. Or maybe you understand that maybe you have an issue with theft. So maybe you've been saying 20% and you want to drive to 10% because you realize that, hey, we figured out this theft ring and it's not happening anymore. So we don't have to buy so many extras. So there just are many, many different reasons why you want to have a standard fleet calculator. Because if you're changing numbers, adding your extra, amount for loss or repairs, and you change that back and forth, that can be very confusing. You also want to have some sort of template for a packaging business case, which is going to be, your expendable versus returnable, whether you, do this by hand or maybe you have software that can do these calculations for you. You want to have some sort of standard template that you use every time. So every single time they ask you for the for the numbers for expendable versus returnable or any sort of business case for packaging, you want to always use the same format to calculate that. It makes for more uniformity, and it's more of a trustworthy way that you can run these business cases. And then also a form for people doing proposals. So if you have, a supplier that wants to send you a certain pack, this is your chance to review. So when we were looking at this, when you start looking at, design and prototypes and testing, and they start filling out their proposal forms early on, you want to follow that proposal form, look for any changes, and eventually you will approve or disapprove that form, and eventually get to the pack that you feel is working for all the factors that you've looked at. And then I mentioned again, like the pack revision form. If you know that changes need to happen to to a package, you want to have a form so that, either you fill it out and you have a record of it, or maybe this change is being proposed by someone in manufacturing or someone at the supplier. Part of the beauty of lean manufacturing is that, as you saw in that Ford Rouge video, they had workrooms for the operators, for the people that work line side, where they can implement their own ideas. So, maybe they decide that they need to revise the packaging. Maybe the packaging is too tall. Maybe it's, the dunnage is kind of loose and it's actually causing parts to move. And if you make the dunnage a little bit tighter, you can actually get more parts in. So not only are you reducing the movement and shifting that could damage the parts, but you also could get more parts in a pack, in a truck, and use fewer trucks over the life of this the vehicle build. So there are a lot of reasons why you might have pack revisions. Or they just may be flat out failure. So you may have a pack that a supplier proposed to you, it looked good, but sometimes they just don't work out for various reasons. Or maybe the suppliers figured out a way to have some cost savings for you. They would fill out a pack revision form and say, I'm looking at making this change. So again, the type of forms and standards that you have really depends on what works for you. But these are some things to keep in mind as you start setting packaging standards. Some other things when you look at like packaging standards, or when you talk about the containers, trying to stay with standard totes for automotive when it comes to the packaging, as well as standard pallets. We talked about this before. Another thing to keep in mind is that when you have packaging that is on the line and it's on the rack, so you have a handheld tote, you noticed during the Ford Rouge video, on the racks, they had totes and boxes, but they also had rails, and it looked like they could just put the tote on the rail and it would slide down and it would stay in place. And each of these rails had a part number. They had dedicated material to that particular slot in the line side display. Those widths of the packaging, of the racking to hold the packaging, they are standard. So for example, the 15-inch width is very common because you've got a 48 by 45 pallet, which means on that 45 side, you can get three packs on a pallet. So you can get, 1, 2, 3. For whatever reason, you can get, 3 this way. So when you take that pack off, put that pack on the line side rack, it slides down, and the operator goes to reach for it. They can just pick it up, and it's sitting on this, this rack, and it slides down here and it's facing them to, hold the part. So, those are some examples of how having standards really helps, because when you have standard totes and the racks are set, you can have modular racks that are set up for specific, pre-assigned sizes of the packaging on those racks. So it's very modular and easy to swap out. So let's say you have a new part, you can replace that part with the new part, and it can be in the same tote, and it could fit in that same spot because that's where the operator is installing the old part for the old vehicle. You switch to the new vehicle, and they know that that widget that they had on the old vehicle, this new widget goes onto the new vehicle, but it's going to be installed in a very similar manner in almost the exact same spot in the new vehicle as the old vehicle. So it reduces the amount of training time by having standardization as well. You can get you can get better pricing for some of the standard packaging because these are pre-made and preset, they're not custom, and you could possibly buy some of them in bulk and save on a volume discount. Also, when you have standard packs, it helps you to say, I have existing containers that worked for the last program. They are in very good shape. We could just use them again on the new program. So they would redeploy them. So they pull them in from manufacturing when the manufacturing stops for that vehicle. They set them aside, store them temporarily, and as soon as the new program that they want to use comes in, they just pull those from that inventory and use them going forward. And then when you have totes that have dunnage, I showed you before how you can remove dunnage and use that same, you can use the same pack and you can take the dunnage out. And now you have this dunnage, versus this dunnage for a different part. So once this vehicle, you're done with the vehicle and you have parts that fit in this pack. We'll just use that. So let's say this part fits in there. You've got a bunch of parts that fit in here. Okay, now when you get that new part for the new program, now maybe it's bigger and it fits in there instead. So, but you use that same tote because it's still in good condition and you can save money. But having a standard pack allows you to do that because, you're using the 48-45 or 12x15x9 tote, whatever that is, you can, reuse those if they're in good shape. So those are some advantages. Here we also have, pallets. I'm not going to harp on this too much, but, having some standard sizes for pallets, these are the international sizes, right? So you got the 1200 by 1000 millimeters. This is the equivalent, it's not the same size, but I would say as far as like usage across automotive overseas, they might use this pallet where we're using 48x45. Then you see you've got like the sea container. The size for that would be 36 feet by 30 feet by 45 feet versus another international sea container. Be another size that you have would be like a 47 foot by 45 foot by 45 foot. So, very big containers, but it's good to know what those sizes are, because then you can start looking at, how do my containers fit? How do my bulk containers fit? How do my totes fit? How do my pallets fit in these containers, the sea containers, versus them being on a truck? And plus, if you're using standard size pallets, these international pallets, knowing what that is, you can expect to see those come in versus saying, why are these not on the grocery pallet, or why are these not on the 48-45? You understand that if they're on a sea container, they're coming from an international shipment. You can also, maximize the number of parts that fit on a vehicle, because you already know from standards how many pallets you're going to have, and you're not going to have a truck that has this pallet versus this pallet right next to each other, and that's just going to cause kind of a headache and a nightmare, and you're not going to utilize all of the space on a trailer by doing that. And then other things that you can look at, you know, the dunnage. If these bins are collapsible, is it possible to make the dunnage collapsible? So I don't have this video here, but there's a video of this where it's lays flat when it ships. When you open it, this dunnage fans out, and the parts will fit in between, and it's equidistant. So once you open this up fully, you actually have straight cells in there, horizontally sized cell. Okay, so I just want to talk a little bit about expendable packaging, because I'm going to go and talk about the returnable packaging and finish up this lecture with that. But so the criteria for expendable packaging, again, these are things that you don't traditionally put in returnable packaging. And you may or may not have justification financially, or maybe just from a standpoint of material handling, it may not make sense for these to go into returnable packaging. So the criteria would be things like nuts, bolts, and fasteners. Those always go into expendable 99% of the time, I would say. I very rarely do I see them coming in a returnable. Things that are coming from Mexico. I'm boring myself, I'm sorry. Okay, now actually I'm a little chilly, so I always yawn when I'm chilly. I don't know why. Okay, Mexico shipments. Depending on where they are, where it is in Mexico, what border it's crossing, what protocol the manufacturing locations in Mexico have with border crossings can impact whether or not they're expendable. People tend to shy away from anything that's not domestic, or maybe some things are coming from Mexico or going to Mexico, or overseas shipments. Those are things that, you might want to look at. Does it make sense from a cost perspective, from a freight perspective, to have expendable versus returnable? Another one is, if you're more than 500 kilometers from shipping the product from the supplier to, the customer, whether it's an OEM or maybe it's a sub tier to a tier. Let's just for fun calculate or convert those 500 kilometers to miles. And there may be some of you all in the audience that know how to do that. I used to know how to do it, but I will admit now that I don't. So I have my handy dandy metric conversion app on my phone. So we are going to take the length, right? And we're going to go from kilometers to miles. Okay, so here we have 500 kilometers. And 500 kilometers, according to my handy dandy converter, is going to be just over 300 miles. So we don't really care how many yards it is, but it's about 300 miles. So anything really over 300 miles, it's gonna really, you want to look at it from a standpoint of doing a business case, because the further out you go, the more of an impact the cost to ship, handling, transportation, all those things come into play, and they may be high enough to justify going with expendables. Next is your weight restriction. Oh, I'm so sorry. Okay, the weight restriction for boxes, you're looking at, 35 pounds for OSHA. Like I said, you've seen throughout this series of lectures, you've probably seen anywhere from 40 pounds to 35 pounds to 25 pounds to 20 pounds. It's literally been all over the place. But really, this is telling you the ergonomic decision points at your company is going to drive the maximum weight for handheld totes. OSHA is higher than what automotive standards are. But you want to make sure that you have the weight restriction on boxes that are handheld. You also have to remember that because one of the biggest expenses related to packaging is how they ship from a freight standpoint, you want to make sure that the parts can withstand the loading, because it may be created to this packaging may be created to not be loaded on top. So, you see that little cone that says do not stack, as if the fork truck driver is going to see it in a driving into a dim truck, and he's got a load in front of him. He cannot see a little cone that is about this big, sitting up 6 feet high while he's on a trailer. Basically, this is what he's going to see. And that cone is way up here. So you have to assume that the packaging will get double stacked. So again, there's a load in the truck like this. They put a little cone on top saying do not stack. The truck driver doesn't see it. They're in a dark truck. They go to load it. They drop this on the load that's already in there, and this is going to crush anything that's on it immediately. If there's a little paper corrugated box cone that says do not stack, that truck driver has never seen it. So, those are just things to keep in mind. Assume that whatever pack you have is going to be loaded on the bottom layer of the trailer. And it could be stacked up to 100 inches of something else on top of it. But just keep those things in mind. This diagram I wanted to show because I think it's really important to look at when you design your packaging, think about all the opportunities for these parts to get handled, touched. Those are all opportunities that the part could get damaged. Okay, so you're gonna have things that are mechanical, like fork trucks, and you're also gonna have manual. So manual could be someone picking it up and dropping it. It could be maybe someone is wearing a belt that scratches the part. It could be just the way the person sits something down on the table. Maybe something is meant to be upright, and when they sit it down, they turn it and cause damage. There's just so many things that could happen. So, when this chart I made shows as you go through a basic supply chain, all the opportunities for damage just from manual handling. So at the supplier, you could have, loading it in a pack, moving the pack around, putting the pack on a truck. It gets shipped. When it gets shipped, it can get loaded on the truck, unloaded from the truck for whatever reason. And then it's going to go to the distribution center. And then from the distribution center, it's going to get moved. It could get moved to a supermarket. Okay, assuming this is cross dock, it's not necessarily going to sit. It might sit for a short time, but it's maybe going to get picked up by a fork, the whole unit load, and moved to the supermarket once it's stored. And then in the supermarket, there's an opportunity for handling, because you might pick, instead of a whole bin, you might be taking out individual parts, because now you're maybe doing kitting, or maybe you have smaller volumes. So you're pulling from a large bin. Maybe it's sequenced, maybe you're doing sequencing. So now you're pulling from a larger bin and putting it into a bin to sequence it. Or this bin is coming in sequenced and it's going to the supermarket for kitting. So there are just many different scenarios that you're looking at. Next, do you need to unpack any of these products from the packaging? to get them onto the line for installation. Sometimes you might have an inspection process. Here at the supermarket, maybe you're, taking things out the packaging, and then that packaging is going, straight to a compactor. But here, maybe you're doing some inspection and maybe you have to repack it. Maybe you know that you have an issue with damage for certain items, or you got an alert that something's defective. So, you're looking at a defect and now you have to maybe do an inspection. That's an opportunity to damage the part. So maybe you're inspecting for one thing, but while you're handling it, someone on the floor is handling it in inspection to inspect it, maybe they cause damage some other way, whether it's in the package or not. And then from here, it can go to assembly. In assembly, they might be taking it to, the package. You take it, once the packaging is empty, they're taking it and putting it into a compactor, which could go to the landfill. If it's returnable, it gets emptied and then it gets shipped back to start that process all over again. So this is a general layout flow chart of how an expendable pack right here may go through. But I also put in here, if there's a returnable, it might get shipped instead of discarded. So there are a couple of different decision trees, but mainly this is looking at expendable, because it's probably going to get handled a little bit more with the expendable, because it's going to get, the box is going to get opened up. You have an opportunity, even though you're not supposed to have the sharp object, it could get cut. Those are some of the things that you're looking at. Okay. Now I kind of want to segue into returnable packaging. So this is something that I think is important to really think about as you start looking at justifications for returnables. Sometimes, even though people are using returnables, they don't always understand the full impact, or why we're doing returnables, which is one of the reasons why I gave you the extra credit to watch that video, to understand the impact if you look at the before and the after. So here's something. This was a white paper that was done by Deloitte when they talked about supply chain and automotive. They said that just in North America, you're looking at $5 billion to $10 billion a year is spent for returnable containers. I'm sorry, $5 to $10 billion is spent on packaging, and 30 to 40% of that, at least a third of that, is returnable containers. If that makes sense. So, the automotive industry, they say that about 7% of their budget overall for the company is using to replace returnable containers. So containers that were not meant to be disposed of, they estimate at least 7% is getting thrown away. So with that being said, and that could be bulk bins, it could be handheld totes, and it could even be racks. Like I said, if you drive on the freeway, sometimes in the Metro Detroit area, you'll see on some of the overpasses near manufacturing facilities for automotive, you'll see racks just stored and they are just rusting out. That would be an example. Okay, so this is something that I pulled this one out because I was looking at some of my old presentations and I wanted to include this. So what if we treated returnable containers as assets in the system? So if any of you have worked in automotive, you'll see containers, the blue containers, the black bulk containers, any of them, they will be all over the place. They're not always just on the floor holding parts. And then sometimes you'll see containers that are empty and they're not staged to ship back to whoever the manufacturer is. They're sitting around and they're getting used for other things. So even though, these aren't necessarily considered assets, you'd be up in arms if you're at your desk and your desk chair is gone or your computer monitor is gone. Okay. These items cost about the same, maybe even less than one bolt bin. So I've tried to remind people as I go through some of, some like workshops or things like that. If I ever get the opportunity to talk to people, I say, think about this. This is worth about the same amount. This is actually considered a company asset. These are not considered assets. These might be considered an expense. But if these things disappeared, people would be having a fit. So look at this. If you walked in somewhere and you saw a bunch of chairs that were piled up, office chairs, you would think something is wrong. If you saw a bunch of, chairs or desks piled up in a warehouse like this, you would think, wow, that's really weird. But people don't think anything of it if they walk into a manufacturing facility or a warehouse and they see containers stacked in the exact same way. Or if you walk into someone's office and you see someone sitting on the floor because, oh, look, he decided to take the chair for a ride and the chair is gone. People would think that was very odd if someone's sitting on the floor because they don't have a desk and they don't have a chair. Or the monitors. What if you went in, there's a warehouse just stacked full of monitors in a production facility? People would think that's absolutely crazy, but this is the same exact thing, to have returnable containers just sitting empty that you've paid for, that you've invested in. So whenever I get the chance, I remind people to keep that frame of reference in mind. I want to talk a little bit about justifications and when you're making a decision to change containers. And also have an implemented container management process. So some of the things that you're looking at, why are you looking at changing your processes and maybe changing the type of containers that you're looking at? There are things like loss we talked about before. Reasons for loss could be, theft, damage. The cost may go up for the packaging for whatever reason. You may have to make purchases for unplanned expendables. So that would be the backup expendable packaging, which means that if you're using the backup expendable pack, it means that you are out of returnable packaging. You bought returnable packaging expecting to have enough, but for whatever reason, you don't have enough. Maybe the volume went up. Maybe the packaging is getting damaged. Maybe the packaging is not getting shipped back. It's sitting in a backyard somewhere with scorpions and snakes and people don't want to touch it. Or maybe they're just, like I said, flat out getting stolen. Or if like I said, the volume increases, that can cause a shortage very quickly. Now, but in doing that, many times some people just kind of, oh yeah, we need to have enough. We'll just add a nice big buffer to make sure we have enough. But that doesn't always make financial sense either, because now you're spending more money than you need to. So, how do you make these decisions? A lot of companies don't have the information that they need to make those decisions. So how do they come up with the return on investment? The calculations that we've done in this class are pretty straightforward. Sometimes there are other factors. If you're looking at implementing some technology for that, now, you want to look at like multiple vendors if they're available and compare, pros and cons, what the cost is versus whatever your score might be. So you might come up with a score based on, their capabilities. Do they meet your needs, or are they giving you a bunch of bells and whistles that they don't need? Is it accurate? All these different things. You want to also understand data collection. Are you collecting information from program to program? So as you come up with a new program in your company and they start talking about concepts and ideation, and you give some sort of estimate for packaging, the more data you have, the more history you have, the more data you're collecting for existing production. When it's time to do some calculations and some estimations for a future concept, you can get much closer, and that can help with that justification, because that concept phase, part of it is from the program team and the finance team to say it's worth it. We've got the volume, the product we can make enough money off of, and we're not going to lose money by doing this. So there's a demand for it, all these sorts of things. You also want to look at like vendor selection. If you're looking at new packaging or new processes for your containers to manage them, do you have a vendor that can help you come up with how to manage it? And then you've got to do a business case. So the return on investment is really good to say returnables versus expendables. You're also going to do is if you do a business case for, putting in a new process, whether it's, the way you're handling them, maybe you have some equipment, maybe you have some software, maybe you buy more packaging, whatever you determine to be your improved process for container management, you have to come up with a business case to show it's going to save money. So you're going to basically have a return on investment for that new process, which would include your return on investment for that you did earlier for expendables versus returnables. And then you're doing all that because you might have to get funding. You may need to request funding and get approval, just like the ROI to purchase like the initial packaging for returnables. For a program, you have to basically, you're doing a return on investment to request capital, request money, request funding for the purchase of the containers. You might have to do that as well if you're implementing some special container management process. Okay, so speaking of that, I just want to talk about like what technology is available as it relates to returnable packaging in the automotive world right now. So, we've got like radio frequency ID identification. So this is basically putting some sort of RFID tag on your package, and it can be read, and then you can tell at any given time where this package is. So if it's something like, doing an inventory for chip pallets, they're all chipped. How do you do the inventory with an RFID reader? How do you know what containers have come into a building? You can do that. If you're doing, if you're doing cleaning and repairs, you can see all these are repaired. So if you look and you say you have a bunch of containers and they're sitting in the building, they just came off a truck. Maybe this came off of one truck. This was a clean truck. This came off a truck that the packaging hadn't been cleaned, but you didn't see where the truck driver got it from. If you got RFID tags, you can scan it and say, oh, you just read it. You don't have to like scan the barcode. You just do a read it and say, oh, you know what? These are the clean ones. These have already been cleaned by the vendor. This one hasn't been cleaned by the vendor. We need to put this on the truck for cleaning. So, there are just a lot of things you can do. It gives you history, as I mentioned before. If you have history on existing or previous programs, when you have concepts for new programs, you can really dial in pretty quickly what the estimates are and be pretty accurate. And that can help. You can actually, help win business that way, because sometimes you can lose a bid just because you're or a company could lose a bid because their package costs are too high. That could throw everything off. Okay. So, when you're looking at justifying purchases or changes, you're looking at things that can impact the return on investment. What type of packaging is rolled out, what type of technology is rolled out, You know, you're looking at, do you want something like, you know, RFID tags, or do you want to have some sort of like database for your packaging information? It can help when you're having meetings or discussions with other teams about packaging and about what the product is doing, where how the product's going to be shipped, and what some of the contractual details are as it relates to the part and packaging that are important. That all that stuff can be housed, you know, in one place if you got the, you know, the technology that works for you. Okay, so now I'm kind of jumping a little bit to now phasing in more and more into the criteria for returnable packaging, right? Um, we talked about for expendables, if you're shipping more than 300 miles or 500 kilometers per day. Now, this is if you look at returnables, you're shipping less than 300 miles per day. You might have small pack quantities. Those could be good candidates for returnables. You need some specific part protection where, you know, you have either a sturdy outer pack or you have specialized dunnage as needed. You might have a weight restriction. You can say see here that while I was talking about, you know, 45 pounds for an expendable pack, because a lot of those carry, you know, you carry fasteners in those in automotive. You only maybe have a 30-pound maximum weight for the handheld totes. So they're sturdier, they can hold more, but you know that people are going to be carrying these handheld totes around more often. So they're not going to carry something really heavy for an extended period of time. Let's say that this handheld tote, let's say they're running 1,000 parts per day. This handheld tote holds 200 parts. So that means they'd have to have 5 of these bins every day, you know, or every shift. So, you know, they're going in here and they're pulling these parts out 200 at a time. And, you know, that can be somewhat repetitive. And if you're using standards, you know how many are going to fit on a trailer, how many can fit on a line side rack. Do you need dunnage for these parts? You know, those are just all the things that you look at. You know, you looking at things like, you know, increasing your return ratio by changing the type of knockdown container, what the ratio is for knockdown, and as well as having collapsible dunnage. Those are things that are really helpful when you start looking at, you know, designing for returnable packaging. Now, keep in mind, one of the things that we went through in the last lecture, in lecture 17, was sustainability, right? So we had sustainability goals for returnable packaging. But you really, now you don't really, you know, you're not really looking at that. You're looking at you know, how to improve that return ratio. Avoid shipping racks when possible, but we know because shipping racks take up a lot of volume, they are, from a volume standpoint, they're fairly common. From a number standpoint, they're not as common. You try to avoid them. And then, you know, you want to consider the freight impact, right? How does your freight for returnable in the size and how many times it's been returned? What's that ratio for a knockdown container? What kind of impact does it have on freight? Okay, now I just want to go through, you know, as I wrap this up and get closer to the end, I want to go through elements that you are using when you calculate the fleet size. So I know we went through the fleet size, and I have like kind of in detail, I kind of wanted to go through some of these things. So, you know, for the sake of the calculation exercises, you know, the examples that we're talking about, we're referring to packaging for an individual part. and it's ordered separately for production. And you're looking at like the model or the color, left hand or right hand. So we're just looking at one of those. So these are the elements that are needed when you start looking at the number of containers that you need. Your annual volume, which can be the number of parts produced per year, the actual number of days in the year, which would be your production days. So you're taking out like holidays and shutdowns for inventory, taking out, weekends if you don't work weekends, that kind of thing. How many shifts per day are you running? How many parts per container do you have? And then, the amount of parts that would fit into a returnable pack. So, you'll see that in actually the next slide. But basically, because of that, it's the packaging development process, it's really important to make sure that all your activities and all those items that I mentioned just now, those elements align with what the program management team has already deemed to be important for the program, such as, your volume production days. Again, you want to make sure your packaging activities matching up with what the rest of the team is doing. So you don't want to say, I'm going to build a pack and get a fleet based on a volume of 200,000 when the rest of the team is designing, building, managing, and forecasting based on twice that volume, just as an example. So packaging is not always included in the formal process. So sometimes you're kind of sticking your finger in there, you're asking questions, but this is an opportunity to see if your team is not included in the launch process, and you get a form that shows like, the responsibilities and there's nothing about packaging in there. That is your opportunity to say you want a column on the responsibility spreadsheet, and you also want to have your packaging function listed on the Gantt charts that show the timeline for the program. And you also want to look at your standard operating documents and make sure that what you have as far as your activities for packaging are included in the corporate standards. So with that being said, go back to those elements that I just mentioned. As we start looking at that calculation, like I said, we're looking at things like the system days. We know how to calculate system days now. You need to know how many parts are per container. That you want to align with the takt time or your process cycle time on the line. Again, shifts per day, production days, and those sorts of things. Okay, things to consider. You want to use that cost for your fleet to determine what the capital investment is. Again, a buffer to 3 to 5% is pretty typical. Though, for our calculations in the homework, we assumed 10. And that's basically because anything over 10% is going to indicate some sort of issue with supply chain that you would want to address. And it probably has to do something with container management, whether it's theft or damage or, holding material longer than planned, driver delays, whatever. You want to make sure that's addressed. Next, you have like your fleet, understanding how many containers you need, and not just containers. As if you have handheld totes, you need to make sure you have pallets, top caps, and all the corresponding packaging dunnage, whatever's needed to go with it. Another thing you need to look at are like the driver hours. This impacts your system days, because if you assume that your driver leaves on a Monday, comes back with returnables on a Friday, and then it's going to return back again on Monday with new product, that could be an issue. That could start pushing it back because maybe they've run out of hours. That return leg, or that one leg, could not be the exact same as the other leg for driving on a milk run or from a distribution center back and forth, or from the supplier to the OEM. Again, when you start looking at things like loss, you're looking at things like theft, misroutes, loss, and damage. Theft is probably going to be the one that could be most elusive, because if you're not collecting data, many times you will find that if there's any theft occurring, it's normally occurring where the data is not really good. The data collection is poor, the management of the containers returning is poor, just a lot of issues that you'd have. So keep that in mind. And then there could be other impacts to the fleet that you want to look at that maybe is specific to your company or your facility, or even to your supplier or your customer along that route. Okay, so things you want to look at related to the volume. You want to make sure that the information that you have is accurate. Sometimes forecasts aren't always accurate early on. They get more and more accurate as production goes and they start making sales and they actually have a better idea. I worked in a different industry outside of automotive, and they would brag. I won't say brag, but they thought it was an interesting piece of information to say that their forecast at the beginning of a new product, the forecast is only 30% accurate. So that can make it very hard to determine. So if you have a 30% accurate forecast and you're basing your returnable packaging purchases on that forecast, and let's say that they're 30% accurate on the low side, they run more volume than they expect. Now you're short containers. Or they run 30% accurate to over reporting, overestimating what their volumes are going to be, selling more than they think. Now you end up with empty containers sitting around the plant. That's an issue. You might want to look at what the demand is and compare that to the forecast and see how close they are, and see which one, maybe at the company you're at, you'll notice over time that maybe the demand numbers that they have are closer to what's happening than any forecast, or vice versa. So you just want to kind of keep an eye on different numbers as far as what's being built, what's being requested, to get a better idea going forward. Because maybe if you find that out that they always over predict by 30% of what they're going to run, that can tell you when you make your fleet calculation that you might want to adjust the volume for your fleet calculator. Also understanding supplier capacity. We talked about this during the assignment where you're calculating the rack rollout. And if you have multiple suppliers to make the same pack, to make the same rack, how do you manage that rollout so that you get enough racks? You don't have too many racks, but then you're also not overtaxing and running any particular rack supplier to the point where they cannot produce good racks. They're just trying to get something out the door. And then lead times. So, lead times are a big deal. Lead times right now, especially since the pandemic, lead times are much longer and they can make or break a project. So keep those things in mind. And again, any other constraints. So, next, we talk about like the volume. We start talking about the annual volume. And again, when we look at the volume, these things are like based on a forecast, based on best guesses, and you always want to kind of keep doing checks and balances against that to figure out, what some of these numbers are that you're using for considerations. The next one is element. It determines like how many days in the year that you're running. How do you get the number of pieces of material that would be manufactured per day, and you can take like your annual number of shifts per day and come up with the daily volume. Next, you have your parts per container. You want to know like how many parts are going to fit in the container, some things that you can use to determine if the maximum quantity, excuse me, is the right number, if it's optimal for your parts for production. So you want to know if the pack will meet your specification requirements when it's filled with product. Also, you want to know if the number of parts that you have per pack, if it ties in with some sort of production volume. So is it a factor of it? So for example, if you're making, 1 part a minute, now you're looking at 60 per hour. So at takt time, are you able to bring in enough that, covers, hours, a couple hours, and like 2 bins or would be 2 hours worth or something like that. Or 1 bin would be 2 hours worth. You want it to be a factor of your production so that you're not 45 minutes in and now you've got to like bring in another container. So now you're bringing a container off of the cadence of what's being built, and it can throw off the whole production line because now they've stopped. Maybe they were like, okay, we can do this in an hour. They're running the route, they're coming back in an hour, but 15 minutes early, they've emptied the bin and now they're waiting on material and the line stops. Again, the cardinal rule, don't ever stop the line, right? And then you want to know, does that loaded container maximize the pallet and truck loads, which we went through the scenarios with calculations to come up with that, to see how many fit on a truck, how many fit in a bin, how many fit in a unit load. Other things you want to do is consider the weight, the size, any line side constraints, and then, the locations in the warehouse that you're looking at. And this will help you when you start looking at what your final pack size is and your quantity per pack. And then you always want to confirm the pack, doing things like the fit check or your testing. You want to make sure that the number of parts in the final pack, you have physical samples to confirm that it fits. Next, you're looking at system days. So as you calculate your system days, you're looking at the total number of days that your returnable pack is going to have before it makes a complete loop in that supply chain. So when you look at the Reusable Packaging Association, their definition of a closed loop system is you go from the starting point of a distribution system through all the intended user functions and the locations in that, and then you are returning back to the endpoint of distribution. And at that point, the asset or the returnable pack is prepared again for reuse, whether it's clean or just returned, stored, whatever it is. In many cases, you will have a cycle where the starting points and the end points are the same. Sometimes maybe it goes through a cross dock on one end, but not on the other end. But many times it's pretty much the same loop. Okay. So now I, want to just repeat again what an example of the formula. So we'll talk about the data that we have here to just go over a volume formula. So we've got a volume of 250,000 parts per year. You've got 250 days of production. once you take out weekends and holidays and shutdowns and maintenance and inventory, whatever it is, you know, for this one, you're running one shift a day. So you're going to take the annual volume, which is 250,000, divide that by the annual volume times the number of shifts per day. So basically you've got 250,000 divided by 250 times 1. So that's really 250,000 divided by 250 to get 1,000 parts per day. So that is how you can figure that out. So first, you know, keep in mind that your daily volume formula, again, will be the annual volume divided by the production days multiplied by the shifts per day. Again, the production days times the shifts per day is going to be on the bottom of the fraction of your equation. And then you're on the top, you're going to have your annual volume. And that's where this comes from right here. Okay. Now, to calculate your system days, you're looking at your transit time, any days on hand that you have, because sometimes you'll have material that sits for whatever reason, because they have some inventory. Maybe when they build, they can only build a minimum order quantity of 4 days worth of material or whatever it is. So what you're going to do is you're going to take the number of system days. You're going to determine that. You're going to add together the number of days needed for your transit time, your days on hand, and then you want to add your process times. So this is where that process mapping that I talked about comes in handy, because you get to see every process that happens along the way, and you assigned timing to it. This is also where your value stream mapping will come in handy. So, you know, these are all lean manufacturing processes. So once you map out that process, you know, you are looking at the number of days for your manufacturing time. You might have time for warehousing, your secondary processes, containment. Maybe you have some mandatory automatic inspection that's going to cause you to have time to hold material. And you might have things like subassembly, kitting, anything like that. You want to count those in there, because that's going to be part of your process time, to keep that in mind. Okay, now here you need to note the number of parts per container that we talked about before. So, you know, we already talked about that. You need to know what that is. And the example I'm just making up is like a gear assembly. It's a large part, it's in a bulk bin, and we'll just say you can get 24 parts per bin. Okay, I'm just kind of using that to get a round number. We'll go back here, and you can see when we did the system days, we added up your transit time, which, you know, I'm just giving you 2 days. You just know, based on the information that you have when you look this up and you do your value stream mapping or get the information from your logistics team or your transportation team, you know, it's 2 days. From your materials people, your production control people, you know that you might have 2 days of material on hand at any given time. For your process time, you know from your manufacturing team that it takes 1 day. And then you know from your logistics team again that it takes 3 days return transit, because maybe, you know, you find out that the driver runs out of hours, or maybe the trip back, maybe there's construction, so they have to go a different route and it adds an extra day, you know, whatever that reason might be. But just understand what that looks like. So now, again, you've got 8 days for your system days, 25 parts per bin. Okay, so now here is the calculation. So basically, you're going to have your system days multiplied by your daily volume, and then you take that and you divide it by your parts per container. And then after you've done all this, then you will multiply a buffer in. So we talked again, that buffer is, we're going to use 3%. Okay. In our homework examples, we use 10%. But let's just assume in this example that this particular supplier or customer supplier loop, they have really good control over their containers and they don't lose them. They keep track of them, and most of what they see is maybe lost through breakage, but not necessarily lost through slow returns, not lost due to theft or anything like that. So, it just may be wear and tear, who knows? But they've determined that 3% is their buffer. So now you're going to take the system days of 8 days, multiply it by your volume, the daily volume of 1,000 parts per day, which we already calculated before that. And then you would divide that by 25, which is your parts per container. And then you're going to multiply all of that by your buffer of the 1.03, which is the 3%. And that's going to equal 320. And that is your calculation. So I'm going to stop sharing my screen. And I think I've covered pretty much everything. Talked about lean, the importance of lean through this. We talked about calculations for returnables. We talked about, return on investments. We talked about a lot of different things in this class. I think it's fascinating. I hope you all found it fascinating too. Reach out to me with any questions. You will see this video posted. Homework is posted as well. There are no questions for homework on this. This is all information that you need to know in automotive packaging. So I, again, hope you enjoyed it. And it was great teaching you in this class. All right. Good night, everyone. Bye-bye.